Hello, everyone. My name is Michael, and I will be talking about Wayland shells for embedded systems. First, about me. You know already my name. I work as an embedded Linux developer at Pengutronics in Germany, and I am part of the graphics team, and that's why I'm also here. At Pengutronics, we work with embedded systems. So what are the embedded systems I'm talking about? These are digital signage. That means the large screens you see everywhere nowadays where you get some information. Automotive infotainment systems. I put the automotive in braces because you have them on different places like planes or whatever. Industrial control panels, like you have big machines and they have some display which interacts with the machines, allows you to control it, allows you to monitor the machine. And to a certain degree, game consoles and VR systems, because they kind of have similar requirements as the other systems. And I saw a lot of them here, and I guess a lot of you are interested in them, so I just put it on the list. So what's the difference between an embedded system and a desktop system? First, you have a lot of resource constraints. They are less nowadays, but still you have to really use hardware accelerators there and watch for memory bandwidth usage. So that's really constraints that you have to deal with in embedded. You have custom input devices. Nowadays, often there is a touch screen, but you also have like custom physical controllers, which are different than what you expect on a desktop system. And usually the user interface that you're interacting with is defined by the system developer. So on a desktop system, you have your desktop with windows, and as a user, you expect to move the windows around and be responsible for placing the windows. On an embedded system, you usually don't want the user to move the windows around, but you as a system developer and designer want to make sure that the window layout is exactly as you want. And this talk focuses on the last point, on how to manage the windows in an embedded system. Common UI layouts in embedded system are just a single full screen application. You run one application, it takes the entire screen, and it shows you there. So not much to do with window management. Sometimes you have systems with multiple outputs, like the front and the back of a screen, or next to each other, or a small screen and a big screen. And you run one application per output. That's also a common setup. Maybe you have two applications and you want them next to each other on the same display. Or you want to have a picture-in-picture that you have one big application covering the entire screen and some video stream or whatever just covering part of the screen. That's also very common for like having a camera streaming into part of your display. Or you have something more complex, like some certain fixed setup where you have multiple applications on certain places on the display, or even more device-specific behavior that moves the windows around when a new application appears or disappears, so it changes the display, the window layout depending on the applications that are running. In Wayland, the window management is done by the compositor. That's different to X. We heard a lot about this. This is one thing that we have here. And usually the layout is done by the shell. So that's something that's implemented into the compositors. If the system developer needs control over the window management, the system developer has to deal with the compositor. Let's look at different compositors that are out there for covering the use cases that we saw before. In Weston, we have the kiosk-shell, which is a single full-screen application per output. So that's really suited for this very common use case of one application. You just fire up Weston with a desktop shell, fire up your application, it will be shown full screen, done. It also works with multiple outputs. You can specify in the config which application is shown on which output. The applications are identified via app IDs, so you have a certain degree of control or are able to identify your application and do whatever you want to do with that. And the Wayland clients can use the XDC-shell protocol, so that's basically implemented by all of them. So clients just work. A bit more about the app IDs. They are part of the XDC-shell protocol. They identify a general class of applications. And the specification explicitly states that these can be used by a compositor to group the windows and know where to place them. The problem is a bit that it's a group of applications, so if you have multiple applications running, they will have the same app ID, even if they may behave differently. Then to a different shell, the IVI-shell. It is for in-vehicle infotainment, so it's specifically designed for an embedded use case. It's implemented it provides the possibility to add plugins to Weston and to add the custom behavior via these plugins. And it has an API for these plugins that can be used to customize the layout. So have multiple layers, have different surfaces on these layers and position them explicitly. So this is very useful for the case where you want to place your window on the screen with your own code. It also has a client protocol that Wayland clients can speak, where there is some mechanism to identify the applications, but I haven't seen that much applications actually implementing this Wayland client, this IVI Wayland client protocol. And one thing that's in the IVI shell is that it's a surprisingly large code base, so it has different parts that are running in Weston loaded as a plugin, and there is even a user space application or a user application that interacts with the plugin. So this is surprisingly large, and if you just need some mechanism to control the windows, you won't use most of that. Then there is the agl-compositor, which is coming off from the automotive-grade Linux. It's also an embedded use case. It's kind of a next step over the IVI application, or a replacement for that. It uses the agl-shell protocol, which for the clients to allow a certain kind of degree. It's different from the IVI shell application protocol, but still clients have to implement it to have a full control over or make use of the agl shell. Identification also happens via the app IDs of the XDC-shell protocol. So that's with the same benefits and disadvantages of the app IDs. It also assumes that your desktop will have like a panel and a background, so there are certain assumptions built into the agl shell about your window layer or how your display will look like. And it uses not a plugin mechanism, but it uses libweston. So it replaces parts of Weston, which is, I'm not sure because if this is a good solution, because you lose certain bug fixes and feature improvements that happen in Weston in the front end, and you need to port them to the agl shell. Or if you use a similar mechanism, you have to port the improvements as well. Then there is not only Weston, but WL roots. If you search for kiosk-shells based on WL roots, the first thing that comes up is Cage, which is a single application full screen use case. Some interesting thing that occurred to me is if you have multiple outputs, it will just scale the single application across all the outputs, which is in most embedded cases not something that you want to have. Because you have a single application, you don't need to identify your clients. And as said, it's built on WL roots. Then there is a game scope, which is for a single application full screen using X11 applications. It's optimized for zero copy using lib liftoff, which you usually also want in your embedded application for making use of the DRM planes. It has color management support. You also usually want that in your embedded system. It doesn't need client identification. It's built on WL roots, but it's kind of out of scope for this talk because you don't have window management on game scope because it's single application. Then there is FOC and Fosch, the shell for the Librem 5 phone. I put that there because it's also phones are kind of similar to embedded system, just a bit more powered. And what I found interesting there is that the compositor and the shell run in different processes. So the thing that you modify for getting your custom behavior there is not the same process as the compositor. So if you crash in your UI thingies, your compositor may not be or is probably not affected by that. So you have some kind of separation between the compositor and the shell. Another compositor is the Qt compositor, which allows you to use QML for your window management. So this is taking toolkit mechanisms to design your applications and applying it to compositors to move windows around in a really easy and descriptive manner where you just put your coordinates for your windows and allow you to easily manage the desktop. You have the Wayland protocol exposed into QML, so you kind of start to implement a whole compositor in QML if you use the Qt compositor. Then there is an open issue in the Weston GitLab for scriptable window management, which looks interesting as adding a scripting language, in this case Lua, to Weston to allow a certain degrees to manage surfaces in Weston with your own code that you provide as a system developer and not rely on the user. Then I have several questions that I'm asking myself, how to use shells in embedded systems. So regarding custom management, are the hooks for the surfaces in this script enough, or do we need something more like an API or something in the window shell, in the IVI-shell? And do we want to separate our custom code from the compositor code or keep this together? For client application identification, are the app IDs sufficient? What about the same application that runs multiple times? This is, for example, relevant for GStreamer. If you run multiple GStreamer pipelines, they will, I'm not sure if they set the app ID at all. So that's a problem. And do we need or want a protocol for clients to identify against the compositor? Do we need something special here in embedded? Is there something missing in the XDC shell, or can we just rely on it? And we need support in the graphic toolkits for that. There are some further concerns for embedded systems. I won't go into them. And with that, I'd like to thank you for your attention. And I have a lot of questions. If you have answers, remarks, different opinions, or other questions, come to me, talk to me, and ask them. Thank you.
Hello, thanks for the talk. I just want to point out that for GameScope, we do have window management. So there, by default, the mode that you describe is correct. Like single application, we just display it. We have a managed mode, which is what we use on Steam Deck, where you can tag applications by ID. And then there's a programmatic interface you can use to switch between apps, switch between windows. So it's not, there's not like a window decoration or something you can drag windows around. It's more for something else to act as a shell or some scriptable thing. We can extend that to, we already have pop-up windows and a bunch of different things that, that fit our use case, but I think it could easily be extended to support arbitrary position and kind of an arbitrary scene graph or anything like that, if that would be helpful for you. I don't think it'd be a giant change. So okay. We should chat more, I guess.
Okay, thank you. Yep.
Yeah, hi. Thanks for the presentation. I just want to point out that in Cage, there is an option to change the behavior of full screen window. So it doesn't have to occupy the whole monitor space. There's a command line option you can change to change the behavior of that to be per screen. And I maintain Cage, so if you have any questions, feel free to ask. In terms of client identification, one option would be to use security context protocol. We have recently standardized with the instance ID. You can basically wrap an existing Wayland client without modifying it and attach some more metadata, like an instance ID and custom app ID or something. So maybe there's a solution there.
It's the session or security? I didn't catch the...
The name of the protocol is security context. It's designed to be used by Flatpak and other sandboxing stuff to be able to reliably identify, this Wayland client is running in this Flatpak sandbox, and without any kind of PID races and unreliable hacks to get back this information. But it could be used, I think, for more precise client identification as well.
Okay.
Yeah, maybe an option.
Okay, thank you.
Hi, thanks for your talk. One thing that I was missing is also GNOME kiosk, which is basically, it's based on Mutter, but without all the bells and whistles around GNOME shell. Mm-hmm. And so it's specifically meant for kiosk things. And it also has this kind of scriptability issue. So I wonder if that's also something that would be interesting to collaborate on at some point. Because I think that would be cool to have, really. Yep. I think we miss something really here in the Wayland world. So yeah, thanks.
Thank you. I don't see any more hands. So 3, 2, 1. Thank you again and have a nice lunch.